There is an aircraft in the U.S. Air Force inventory that most people have forgotten about. It is not stealthy in the way the B-2 is stealthy. It is not talked about the way the B-21 is talked about. But right now in 2026, it is going through one of the most aggressive and consequential overhauls in the history of American air power. We are talking about the B-1b Lancer, a supersonic strategic bomber that was designed to punch through Soviet air defenses at low altitude and high speed, and which is now being retooled to defeat the most sophisticated air defense networks on Earth. What they are doing to this aircraft is extraordinary, and almost no one outside the classified world knows the full picture. Leave your like, subscribe, and share. Let's begin. The B-1b Lancer has one of the most turbulent histories in American military aviation. The program began in the 1960s as the AMSA, Advanced Manned Strategic Aircraft, before evolving into the B-1A, 4 prototypes of which were built and tested in the 1970s. President Jimmy Carter canceled the program in 1977, concluding that cruise missiles could perform the strategic penetration mission more cost-effectively. Then President Ronald Reagan revived it. The B-1B, a substantially redesigned variant with reduced radar cross-section, variable sweep wings, and advanced electronic countermeasures, entered service in 1986. 100 aircraft were built at a cost of approximately $280 million each. From the beginning, the Lancer was a compromise, not as stealthy as what would eventually become the B-2, not as long-ranged without refueling as some planners wanted, but enormously capable in its combination of speed, payload, and low-level penetration performance. The numbers behind the B-1B are staggering. It is the fastest bomber in the U.S. inventory, capable of speeds exceeding Mach 1.25 at altitude. Its variable sweep wing, which can be swept from 15 degrees to 67.5 degrees, allows it to optimize aerodynamic performance across a wide range of speeds and altitudes. At full sweep, it can dash at high speed to evade interceptors. At low sweep, it is optimized for low-level terrain following flight, where it can exploit the radar shadow of the Earth's surface to approach targets without being detected by long-range surveillance radars. Its unrefueled range exceeds 5,500 miles, and with aerial refueling it is limited only by crew endurance. And its payload, up to 75,000 pounds of weapons across 3 internal weapons bays, is the largest of any aircraft in the U.S. Air Force. For context, that is more than twice the payload of the B-52H. But the B-1B has faced serious challenges. The aircraft's original nuclear mission was stripped from it in 1994 under the START Arms Reduction Treaties, which required the bomber to be converted to conventional-only operations. The ALQ-161 defensive avionics system, the sophisticated electronic warfare suite that was supposed to protect the aircraft during penetration missions, proved unreliable and was partially disabled, leaving the aircraft dependent on standoff weapons and electronic warfare support from other platforms. In the wars in Afghanistan and Iraq, the B-1B found a new role as a long-duration close air support platform, flying for 12 hours or more at a time, available on call to troops in contact, dropping precision-guided munitions with devastating effect. It became beloved by ground forces for its persistence and payload. But that was a permissive environment. Against a modern integrated air defense system like those operated by Russia or China, the question of how the B-1B would survive became increasingly urgent. The answer that the Air Force has developed is the B-1B Lancer Defensive Systems Upgrade Program, combined with a sweeping set of modifications under the broader conventional modernization program. Together, these upgrades are transforming the aircraft from a Cold War-era penetrating bomber into a standoff and long-range precision strike platform with enhanced survivability tools that would have been unimaginable when the aircraft was designed. The centerpiece is the replacement of the ALQ-161 with a new integrated electronic warfare system. The details are classified, but what has been confirmed is that the new system uses modern digital radio frequency memory technology, DRFM, which allows it to capture, analyze, and retransmit radar signals in ways that create false targets, corrupt tracking solutions, and deny adversary fire control systems the information they need to guide missiles. Against the S-400 and the S-500, this capability is not optional, it is existential. The weapons integration story is equally transformative. The B-1B's 3 internal weapons bays, the forward bay, central bay, and aft bay, can carry a vast range of munitions. But for years, the aircraft was limited in the most modern weapons it could employ. The current modernization program integrates the long-range anti-ship missile known as LRASM, which gives the aircraft a devastating anti-surface warfare capability against adversary naval forces. The LRASM is a stealthy autonomous missile that uses a combination of GPS, inertial navigation, and terminal infrared homing to strike ships at ranges exceeding 200 nautical miles. In the context of a potential conflict with China in the Pacific, a fleet of B-1B aircraft armed with LRASM represents one of the most significant anti-ship strike forces ever assembled. Beyond LRASM, the B-1B is being integrated with the Joint Air-to-Surface Standoff Missile Extended Range, JASSM-ER. The JASSM-ER is a stealthy cruise missile with a range exceeding 575 miles, a 1,000-pound penetrating warhead, and a two-way data link that allows targeting updates after launch. A single B-1B can carry 24 JASSM-ER missiles internally, making it arguably the most capable standoff strike platform in the world on a per-sortie basis. In a scenario where adversary air defenses prevent direct penetration, a flight of B-1B aircraft armed with JASSM-ER can strike targets across an entire theater from outside the defended envelope, overwhelming even the most capable surface-to-air missile systems through sheer volume and the missile's own stealth characteristics. The hypersonic weapons integration is perhaps the most forward-looking element of the overhaul. The Air-Launched Rapid Response Weapon, ARRW, is the U.S. Air Force's Air-Launched Hypersonic Missile Program. While the program has experienced development challenges and schedule delays, the B-1B has been identified as one of the primary carriers for this weapon once it reaches operational status. A hypersonic weapon traveling at speeds above Mach 5, some estimates for the ARRW put it above Mach 10, compresses the adversary's decision timeline to near zero. Current surface-to-air missile systems are not designed to engage targets moving at those speeds and altitudes. The combination of a B-1B's range and payload with a hypersonic weapon's speed and kinetic energy creates a strike capability that no existing air defense system on Earth can reliably defeat. The avionics overhaul extends well beyond electronic warfare. The B-1B's cockpit was designed in the 1980s, and while it has been upgraded repeatedly, the fundamental architecture remains that of its era. The current modernization effort is replacing the mission computers with an open systems architecture using modern processors, integrating a new fully integrated data link, FIDL, that connects the aircraft to the Joint All-Domain Command and Control Network, and installing new large-area displays in the cockpit that present fused information from multiple sensors in a format that dramatically reduces crew workload. The B-1B is a 4-crew aircraft commander, co-pilot, and 2 offensive systems officers. And the quality of information presented to that crew directly determines how effectively they can employ the aircraft's weapons in a complex, rapidly evolving threat environment. There is also a significant structural story. The B-1B fleet has accumulated substantial flight hours, and variable sweep wing aircraft are mechanically complex. The pivot points of the wing, the actuators that drive the sweep mechanism, and the structural bulkheads that carry the wing loads are all subject to fatigue. The Air Force has a comprehensive structural integrity program for the B-1B that includes regular inspections, component replacements, and in some cases, structural modifications to extend airframe life. The goal is to keep the B-1B fleet operational into the 2040s, long enough for the B-21 Raider to be produced in sufficient numbers to take over the penetrating strike mission. But that requires sustained investment in structural sustainment that is expensive and technically demanding. Leave your like, subscribe, and share. The B-21 Raider is the aircraft that will eventually replace the B-1B and the B-2A Spirit as the primary U.S. strategic bomber. The B-21, built by Northrop Grumman, is a flying-wing stealth bomber that incorporates 6th-generation technologies, including an open systems mission architecture, advanced low-observable coatings, and compatibility with the full range of current and future weapons. It made its first flight in November 2023, and the Air Force plans to procure at least 100 aircraft. But the B-21 will not be available in large numbers for years. In the meantime, The modernized B-1b fills a critical gap as the only supersonic bomber in the American inventory, with the range and payload to conduct massive conventional strikes across vast distances. The operational history of the B-1b in the 21st century demonstrates exactly why this overhaul matters. In 2018, B-1b aircraft participated in strikes against Syrian chemical weapons facilities as part of Operation Inherent Resolve, launching 19 JASSM missiles in a single strike package, the first combat use of that weapon. In the Pacific, B-1b aircraft have conducted continuous bomber task force missions from bases in Guam and Australia, sending an unambiguous signal to China and North Korea about American long-range strike reach. In 2020, B-1b aircraft flew the longest bomber mission in Air Force history, launching from Ellsworth Air Force Base in South Dakota, flying to the Norwegian Sea and then returning home, a round trip of over 24 hours that demonstrated the aircraft's extraordinary range and endurance. These missions are not exercises. They are operational demonstrations of capability, designed to be seen and understood by potential adversaries. The Chinese air defense network that the modernized B-1b is designed to operate against is formidable. China has deployed an integrated air defense system that combines long-range surveillance radars, the HQ-9B surface-to-air missile system with ranges exceeding 125 miles, the S-400 systems purchased from Russia, airborne early warning and control aircraft including the KJ-500, and a fighter face that now includes 5th-generation J-20 aircraft and is developing 6th-generation successors. This network is designed specifically to deny American air power the ability to operate freely in the Western Pacific, what strategists call A2AD, or anti-access/area denial. The B-1b overhaul is in large part a direct response to this threat architecture. Every upgrade, the electronic warfare systems, the standoff weapons, the data link connectivity, the hypersonic integration, is designed to defeat a specific element of that network. The maintenance and sustainment picture for the B-1b has historically been challenging. The aircraft has one of the lowest mission-capable rates in the Air Force inventory. At various points, less than 50% of the fleet has been available for operations at any given time. The complexity of the variable sweep wing mechanism, the demanding maintenance requirements of the 4 GF-101 turbofan engines, and the age of various subsystems have all contributed to availability problems. The modernization program includes significant investment in reliability improvements and maintenance concept changes designed to push mission-capable rates higher. An aircraft that spends half its time in the hangar is an aircraft that cannot be counted on in a crisis. The geopolitical urgency driving the B-1b overhaul cannot be separated from the broader strategic competition with China. American military planners have war-game scenarios involving a Chinese attempt to seize Taiwan by force, and those simulations consistently highlight the importance of long-range conventional strike capacity in the early days of such a conflict. The ability to strike Chinese naval forces, air defense sites, command and control nodes, and logistics infrastructure from standoff ranges before those targets can be defended or dispersed could be decisive. The modernized B-1b, armed with LRASM and JASSM-ER, is a central element of that strike capacity. It is not an exaggeration to say that the decisions being made about the B-1b today could affect the outcome of a hypothetical Pacific conflict. What makes the B-1b overhaul so remarkable is its ambition. This is not a program designed to keep an aging aircraft limping along until something better arrives. It is a program designed to fundamentally transform a legacy platform into a cutting-edge weapon system capable of operating in the most dangerous airspace on the planet. The engineers and planners working on it understand the stakes. The adversaries they are designing against are not static. They are continuously improving their own systems. The race between offensive capability and defensive systems is eternal in military history. And the B-1b overhaul is the American entry in the most consequential round of that race in a generation. Leave your like, subscribe, and share. Until next time.